Hello class and welcome. In this short lecture we're just going to be talking about basically displaying your data, the distribution of your data to be able to better understand how it looks. Some of our objectives for this unit, again, we want to understand the basic shape of frequency distributions, understand what a frequency distribution is. The reason for that is they become very important later in actually testing some of the different statistical analyses we use in this class to see if they're an appropriate test to use or not. But before we do anything, it's very important just to get a general view of what does our data look like, what does our shape of our variables look like. So that's what we're going to be largely talking about today. So, yeah, first thing is looking at frequency distributions. You can think of a frequency distribution as basically an examination of how many times different events occur in your sample. So we're basically going to look at how you can display these using tables and also different types of figures. Mainly we're going to focus on what's called a histogram here, a particular type of graph that's used fairly frequently when we have continuous data. And I will say your book covers a lot of other techniques, many of those used for categorical data, such as bar graphs, pie charts, that type of stuff. You want to review that, but it's such pretty basic information, so I didn't not covering it in this lecture. And finally, we're going to talk about the shapes of distributions. Once we kind of know how to make it, chart it out, draw a histogram, and see what our distribution looks like for a continuous variable, we'll talk about some important shapes when it comes to that. Alright, let's get started. First, let's talk about what's a frequency. Again, it's just the number of times an event occurs in a population or sample. So if you're looking at a variable of interest, you're usually going to use it to categorize that in some way. And this can be used for categorical variables as well as continuous. For example, with a categorical variable, frequency, you could be looking at the frequency of the number of students in this class. How many freshmen do we have? How many sophomores? How many juniors? How many seniors? And how many future grad students or grad students that need this class to go into the grad program? We could basically chart each of those out and let's say we have 5 freshmen, 6 sophomores, 3 juniors. When we're looking at with categorical data, it's fairly straightforward. But obviously we can also have this with continuous data. For example, the number of people arrested each day, with essentially days here being our unit of analysis, and then each day we would put down the frequency, how many arrests were made that day. Now, what's a frequency distribution? It's basically just a table that shows you the various values for your dependent variable, the various frequencies that occur, so you can see all of them. Now, it's better if we see this in action. So let's get an example here. We'll use a categorical example first. As I said, you can draw out frequency distributions or make them for categorical or continuous variables. Here we just did a very simple one using gender as our variable. Let's say that we arbitrarily coded male as 1 and female as 2. And you see here's our list. Let's say this is the amount of people in a room. How many males do we have and how many females? What's the frequency? Well, our frequency distribution, we would basically create a table with 2 columns. One column would have the variable, and when we're looking at categorical, it just would be, okay, one category in one row and one category in the other, and then you would put the frequency out over here. Usually see frequency, but it's just a lowercase f. So 7 males if we counted out, 6 females. That's pretty easy, pretty straightforward. One thing you do want to remember is that when we're talking about this type of stuff, we represent the sample size as a lowercase n when it's for a sample. So we see here, we count this out as 13, or we could just count it here. 13 is how many people's in our sample altogether. That'll be important here in a little bit. But okay, let's get another example here of actual continuous variables, because this is what we really are concerned with as far as getting frequency distributions in most cases. In this example, let's say that we may using an example of the police response times to calls of service. How long does it take the police in minutes to respond? Now, I gave a couple of values here, 22 altogether, so we have an n of 22. These are each representing different calls of service and how many minutes it took the police to get there. Now, I completely made these numbers up, and hopefully our police are doing a lot better than the numbers that I made up here. Okay, how do we go up making the frequency table here? Well, you see we got a bit more values, so what you're going to do first is just make a list of all the values. I've already put them in order. That's a good thing to do sometimes, but if you have a lot, it's kind of difficult. But then you're just going to, again, draw up that table, and in your one side you're going to make each value, and then you're going to say how many times each value is represented. So for example, we have 10 minutes is represented twice, so we would put 10, and then out from there we would have how many times it's represented. Just to jump ahead and show you what that looks like, if we went out and did the distribution for that, all that data, we would have, okay, response time, so I put X here because again that kind of denotes that that's our variable of interest, and then the frequency for each time occurrence. So 2 at 26, you can see the most here, or 5 response times at 25 minutes. Okay, but this is all really easy and straightforward, so we're going to move pretty quickly. It's probably the easiest chapter in this book. Okay, one thing we can look here, that's a fairly decent amount of frequencies to draw out. If you're looking at most real data, you're going to even have a lot more than that. So what we often do is make grouped frequency tables. And essentially what we do here, we group different values into intervals. Intervals being, okay, let's say we had, instead of saying 10, 11, 12, 13, 14, we could say 10 through 13, 14 through 17. And essentially that's going to make our table just smaller and make it more manageable, particularly when we have a really large amount of values in our variable. And that's really the main reason we do this, because we often do have a lot of values, and this is a good way to simplify it. A good example, a lot of my own research is on digital piracy, and one of the questions I often ask for my dependent variable is how many times on survey research. A lot of my research is giving surveys out for self-report data, but let's say that we're giving out a survey as self-report data asking people how many times they participated in digital piracy over the last year. Well, I can tell you that you're going to get a pretty big range on that. I often get, you get a lot of people that say 0, but then you have a couple that do it maybe 1 to 10 times. But then you're anywhere up to even into the thousands, so you have a huge range of values. So in that case, it would be very good to actually make a group frequency table rather than a traditional frequency table. Okay, let's just show our example here. We took our same values that we had from our last frequency table. I want you guys to try to make this yourself before you go and view mine. Get out a scrap piece of paper and try to draw it up. Let's say we wanted to do a grouped frequency distribution for this. So the first thing we got to do is make the groups. So the best way to do that is subtract the lowest value that we have, 10, from our highest value. That's going to give us our range. So if we do that, we get 16. And essentially what we're going to do is figure, okay, what's a good number to divide 16 into? I'd say a good one here would be a range. Divide this range of 16 into would be 4. So we're going to set intervals of 4. You could do 3, you could do 2. But for this particular case, 4 seems like it'd be a pretty good number. So that should give us basically 4 grouping categories. So what you guys to do is to go through here, make a list of each of these, and make a grouped frequency distribution using these guidelines. So you might want to pause the video for a second because I'm about to go over my results. So I'll give you a second to do that, but then once you're done doing that, come back and view the actual results here. Okay. So what it should look like is something like this: 10 to 14, 15 to 18, 19 to 22, 23 to 26, and then the frequency. Once again, pretty straightforward stuff. Some other stuff we can talk about is sometimes you'd want to get the relative percent or relative frequency in a distribution. And it's basically sometimes just to make it easier for people to understand and make your frequency table easier to understand, you want to present the frequencies in percentages as well. So in case you don't know how to calculate a percentage, you would just take the frequency of a value, divide that by the total in the sample, and then times it by 100. So what I want you to do real quick is go back to our group frequency distribution that we just made and calculate the relative percent for each row, for each interval. So once again, pause the video, take a little bit to do that, and then come back. Alright, well, you should have got something roughly along the lines of what we see here. Okay, percent here, it should be around 36.35. Yours might be a little different based on just rounding, but then, okay, 3 here, that makes about 13.6% of the sample, 1831. You add that all together, it should get close to 100%, although you'll usually be a little bit off due to rounding error. So why is this a good way to present it? Again, it's just much easier for people to just quickly glance at the data and be like, okay, that 36% fall within 10 to 14. All right, let's talk a little bit about cumulative frequencies and cumulative percentages here. It's basically when you're making your frequency table, sometimes what you want to do is create another column where you might give the percentage of that interval added to all the intervals below it. So you're just adding up the intervals here as you go down your distribution. So easiest way to do this is just look at the graph again. You can see that, okay, 36.35 is how many people are percentage here. So our cumulative percentage, well then if we add 13.64 to that, it gives us 49.99 roughly, and on and on. You see we just add them up as we go down. Very easy, very straightforward, so I'm not going to spend too much time on it. Alright, let's talk a little bit about something that's pretty important here, which why we go over all this. This is what we're going to see a lot more with frequency distributions, plotting them out in an actual visual format. And our most common way that we see this is, or the one that we're going to be using the most in this class and referring back to the most, is what's called a histogram, which is basically a graph with rectangles used to represent the different frequencies. It's essentially a bar graph with a couple slight differences. And so essentially what you would do essentially, what you're going to do is place your intervals from lowest to highest over here. So in actual order. So if you can see, if we were doing our interval thing that we were examining was test scores, if that was the variable we were interested in, we would do, okay, lowest test score you could possibly have is 0, highest is 100, and then you would plot it out and say here that if we did a grouped frequency distribution for 0 to 20, this section to section to this section. And then we would plot each of those out. Okay, pretty simple there. Okay, on the X side here, you're just going to have the potential frequencies for that occurring. So in this case, it would be the numbers of students who get a particular score. Now, if we were going back to our previous example, this would be your frequency of the response time over here, your potential frequencies anyway, and then your actual intervals down here. Okay, that's pretty straightforward, but a few things you want to remember. Bar graphs, or a histogram, is different from a bar graph in multiple ways. First is that a bar graph, you're usually going to have spaces between the different variables, because a bar graph you're usually going to use a categorical variable. So you might have let's say, male, female, and then the number of, again, going back to our example of people in the class, you would just draw it out like that. That's a pretty standard bar graph. But in this, because it is continuous variables, they're going to be connected. So each of these is going to be connected to the next. The other difference, again, is that you actually do kind of go in order from your lowest possible to your highest here. Okay. So if you're going to make it, again, we just went through those steps, but the first thing you would do is draw out your x-axis, which is the horizontal axis. Think horizon, watching the sunset. And that's where you're basically going to place the real upper and lower limits and midpoint of your dependent variable, or whatever variable you're looking at, your variable of interest. So you're going to take your lowest value and your highest value and put that on there and everything in between. and then the y-axis is your potential frequencies. And very straightforward. Make a vertical bar that goes up to each frequency, have the bars touch each other. Very easy stuff. But okay, why do we care so much about histograms and frequency distributions? Well, one of the reasons is that the shape of our general distribution for a particular continuous variable can affect various things as we get later into some of these later statistics. I mean, a lot of the statistics you look at have certain assumptions, and you have to make sure that your data actually fits those assumptions. And one of the things we often see is the shape of your continuous variables. What do the variables look like on their distribution? So we often see this distribution plot out as far as histograms. And we essentially want to see the overall shape of it. And often how we see that drawn out, we see the histograms, but we can also see it kind of charted out almost like a line graph. But a few things that we're often interested in when we're looking at the general shape, if we want to look at the shape of our distribution overall, one is symmetry. Essentially, there's certain cases where we might be looking for symmetry in our data. Symmetry obviously being both sides of a distribution being essentially exactly the same from the midpoint. Now the most common symmetrical distribution, the one that's going to be very important in this class that we'll talk about a lot more, and it's going to be a key concept in this class, but we're just going to go over the basics now, is what's called the normal distribution. Now a normal distribution is essentially a symmetrical distribution that peaks at the center and then is symmetrical on both sides going up and down, and it's generally kind of bell-shaped. So it's often called a bell-shaped curve, but it's symmetrical on each side. So if this was number of arrests over multiple days, this could be obviously your very low days, which aren't represented very much, getting up to your higher days and how frequent they are, and then back down to your extremely high frequency days, and it's going to be less of those in most cases. But okay, here's just an example if we were to actually take a histogram and plot a normal distribution over. This is what a histogram, you can see behind here the bars, a histogram of a normal distribution would look about like. Now for now, you just want to remember what a normal distribution is. It's essentially, again, a distribution that's got this bell-shaped curve, and the tails of it and everything on that's symmetrical. It peaks kind of at the center here and tapers off to both sides, which the sides here are called the tails. Now, another thing we can talk about when we're looking at the general shape of our distribution is the skew of the distribution. Skew basically means that it's your distribution kind of seems to lean one way or the other. Essentially, it's a measure of how asymmetrical your distribution is. Asymmetrical just meaning not symmetrical, the opposite symmetrical. So it's showing that your data is not symmetrical. You have two types here, a positive skew and a negative skew. Okay, the first we can talk about is a negative distribution. The negative distribution is essentially the tails pointing to the left. You can see it kind of scales down here. This would essentially represent that on your frequencies you have very little near the lower end of whatever variable you're interested in, and it peaks up near the high end before dropping back off. Let's say if we had a test that was very easy and most people perform very well on it, it might have a negative skew, meaning you'd have very few F's and D's and C's, but you'd have like B's and A's, there'd be a lot, and that's where your distribution would essentially peak. But then the tail again is kind of pointing this way. That's a good way to think about it. This tail here is pointing in this direction. Positive skew is the exact opposite. See, again, it's not symmetrical. This side's different than this side, and then the tail on this one would be pointing to the right, be pointing to the upper end of your frequencies. This would essentially mean a distribution where you have a lot of your frequencies happening at the lower end but not at the top. Very common example in real life data where we see this distribution a lot is a lot of our criminal data, how many crimes have happened. Like let's say the numbers of murder in a city over a year or something like that. And we were to plot that out, or say multiple years, just the number of murders essentially over multiple years. And we were to plot that out over, say, like a pretty large span, we would generally see that, for the most part, let's say this is a very small scale here, we have like 1, 2, you're not going to have very many in a year in most locations. So you have a lot of, let's say, to give you an example of this, let me backtrack. Let's say that we're doing a study on cities around the nation and the amount of murders they have per year. Now again, generally, murder rates are pretty low. So generally our distribution, overall, we're going to have a lot of cities on this lower end with distributions showing maybe like 1 to 20 murders per year, and then it's going to kind of taper off on this end. There's going to be very few on the higher ends. But okay, again, all you need to remember about positive skew for now is, again, it's pointing toward the upper side. So it's pointing toward the positive end, where a negative skew is pointing toward the negative end. Last thing we want to talk about, we're talking about this distributions, is modality. This essentially just means how many times your distribution peaks. Again, normal distribution, we generally have one peak. We always have one peak in a distribution. It's sometimes called unimodal. Modal, again, talking about the peak. Bimodal would mean there's multiple peaks. Trimodal or bimodal would be 2, trimodal 3, and so on and so on. But just keep those terms in mind. Okay, that's kind of finishes up for the lecture. A very short lecture for this week, but your guys' assignment's a bit more involved this week, so I wanted to keep the lecture a little bit short. Also, you guys want to make sure to review the chapter material in chapter 3. Review that pretty thoroughly. And again, there's going to be a few things popping up in the test that we didn't cover in the lecture here, but it's all pretty simple stuff. But you want to at least make sure to read through and know that stuff in the book that's not covered here. Alright, you guys have a great week. If you have any questions about the assignment for this week, feel free to contact me at any time.